Hi, in this Let's Create series, we're creating the classic block breaking game of Breakout. In the last episode, we introduced the ball and paddle mechanics, and in this episode, we're going to move on to breaking those blocks. Let's get started. We're going to need a script to add to each of our blocks that defines the properties of it, such as how many hits it takes to destroy and how to handle the block destruction. So in our scripts directory, create a new C# script, which we'll call block, and we'll dive into the code. The first thing we want to create is the parameters of the block. So under a header, block parameters, we'll start by creating two things you may want to vary. Again, these are all serialized so you can change them in the inspector if you wish. Firstly, a private int called hits to destroy, which we default to 1. You can increase this if you want your ball to have to hit the blocks more times to destroy them. I think I vaguely remember some version of the game having a yellowy gold blocks that were annoying because they needed multiple hits. The second is a private boolean called isDestructible, which we default to true. We'll use this boolean to make the invulnerable blocks. Now when something hits the blocks, we want them to be destroyed. As we're using the physics engine, we can use the onCollisionEnter2D method, which will be triggered when something collides with the block. This works out of the box because the ball is the only thing that will be moving in our scene. Firstly, we only want to process anything if the block is destructible. You could argue, why bother with this and just don't apply the script to the indestructible blocks? That would be a perfectly valid argument. I've included it because you may want to trigger sounds or effects on collision which may want to be different for the destructible and indestructible blocks. So at least you've got a base to work from. The first thing to do here is to decrease our hits to destroy variable as the block has been hit. If it is 0, this means we've hit it the right number of times and we can simply hide the block by calling the setActive method on the game object and passing in false. That's it for now. Back in Unity, let's attach this to our block prefabs. In our prefab directory, I'm just going to select each of the prefabs and add the script to it using the Add Component button. Remember, on the indestructible one, we deselect the isDestructible variable. Now we can start the game and check it out. This is looking great. We're hitting the blocks and they're disappearing, which is kind of the point of the game. Next, let's quickly add a way of tracking the score. So right-click, UI, text to add some text to our screen. This version of Unity that I'm using, which is the 2022 long-term support version, uses Text Mesh Pro by default. So you'll get this pop-up if it's the first time adding text. And you can just select Import TMP Essentials to get what you need into your project. You can then close the pop-up. Let's rename this as score text. We will put this at the top, so open the anchor presets. Hold down Alt so it also sets the position at the same time. We want it a bit away from the edge, so adjust the Y until you get a good offset you like. I used -50. Set the text to 0, it is a score after all, and you'll notice that it's just not quite in the center because the text defaults to left aligned. Just update this by choosing the center aligned option. In our GameManager.cs script, to our Unity objects section, we'll add in a reference to the score text. This is of type tmpro.textmeshpro.ugui. Then we'll create a new private variable, which is an int called score, which starts at 0 to hold our score. We'll add a public function called blockDestroyed, which takes the block score to add. We're going to call this every time a block is destroyed. Firstly, we update our private score variable by adding on the block score passed in. Then we update the UI text to the new value by setting scoreText.text to the string version of our integer score. A simple way to do this is to just call toString. We can do lots of other things in this function, like increase the ball's speed for each block destroyed and check for game completion, but we'll come back to some of that later. So that's it for GameManager.cs. Now in the block.cs script, we need to call this newly created method. First, add a new serialized field, which is an int called score, which we default to 10. This will allow us to have different blocks be worth different values if you like. add a private variable to store our game manager reference in, then add a start method which will be called early on when the block is created, and we'll simply use findObjectOfType with game manager as the type and assign this to our private variable. You'll see people implementing game managers as singletons, finding objects like this, passing in a reference on initialization, etc. There are loads of ways to do it. In a small, non-performant project like this, you can do whatever you feel most comfortable with. Finally, now we have the reference. Just before we deactivate the block when it's about to be destroyed, we call GameManager.BlockDestroyed and pass in the score for this block so that we can register the score with the game manager. This should all be working now. Back in Unity, for each of our block prefabs, I'm going to give them a score. We'll increase the score by 10 for each row. So dark blue can remain with the default of 10, then the blue will be 20, green will be 30, yellow will be 40, orange will be 50, red will be 60, pink will be 70, and finally purple will be 80. Next up, we need to assign our reference in the game manager to drag on our score text to the right place. Now we're ready to hit play and check this out. This is all starting to come together now. As we destroy blocks, we start getting score. And when I get to the next level of blocks, you can see my score go up by 20. Nice. That's it for this episode. We now just have 3 things left to do, which we'll cover in the next episode. Removing the bottom wall, so you actually have to move the paddle, making the ball bounce differently off the paddle based on where it hits, and finally implementing the game's win condition. As ever, the full code is on GitHub and linked in the description below. See you next time.